do you have SPSS installed in your machine? Right. Suppose by now you already have your SPSS installed in your computer. Right. For example, this is a blank SPSS data view, and this is a variable view. Right. So to key in the data, first we need to define the variable. All right. So we need to go to click on variable view. So this is going to be data 1. Let's say for example I name this data as a data 1 and I hit enter. So kalau you nampak dekat sini, boleh besarkan tak? Don't know how to make it bigger.
Can you record?
Yeah. Okay. To key in the data, let's say for example number 13 ni, I nak tunjuk menggunakan data key in data in SPSS, right? So right. So first, before we key in the data in SPSS, right? Suppose you dapat macam ni lah. This is a blank data view and blank variable view, right? So to key in the data in SPSS, you need to define the variable first, right? The variable name, right? And then you need to define what is the type of variable that you want to input, right? First, you need to go to variable view tab, and let's say I just give a name lah for this variable as data 1, right? So bila I hit enter, I type data 1, I hit enter. So you can nampak dekat sini type is numeric lah. So if you click on this numeric cell dekat sini, ada triple dot, right? Triple dot, you tekan kat sini, dia akan nampak variable type. So we have numeric, comma, dot, scientific notation, date, and so on lah. So since this is a numerical data, so we just retain numeric as it is, right? So this is the width of the cell that we're going to key in. This is the width lah, berapa besar cell tu yang kita letak. Decimal point. If you look at this data, there is no decimal point, so that's why we need to put 0 decimal point. So label this data would represent apa ni? Represent mean number of calories lah. Number of calories. So you just type lah number of calories, right? So the missing value. So if you have missing value, you need to define the missing value lah. So later on, if you want, right? Do you understand how to use SPSS? Have you familiar with SPSS before? Pernah guna SPSS?
No.
So, do you want me to give an very short lecture on SPSS? So,
Yes, sir.
kalau you nak,
Yeah,
I can do that. But you create an event, right? Create an event, nanti boleh panggil lah beberapa orang lain, right? So create an event for one day lah, one day event to key in the data and understand the SPSS, how SPSS work and how to find descriptive statistic and graphing, right? So create one day lah, one day event. Nanti bila-bila you bincang lah, you create your own committee, create one day event untuk bengkel SPSS, right? Boleh So let's move out. Nanti you bagi tahu lah leader, nanti leader inform I bila you nak buat bengkel tu, right? So value ni kita biar kosong dulu sebab we don't have any missing value, right? So value ni value hanya untuk categorical variable, right? Missing value is missing value lah. value for categorical variable. So since this is a numerical variable, we don't need to define any value label lah. So missing value. So if you are keying the data, most of the time you need to define the missing value, right? So missing value normally we put as 9 or 99 or 999, right? It depends on your characteristic of the data set lah. So let make it as 999 to indicate this is a missing value, right? So if you have a missing value, then you need to click on 999. So you tak perlu letak kosong ataupun biar kosong, right? So if you type 999 in SPSS, so SPSS will understand that this is the missing value, right? And then you click OK. Column means berapa width column tu, right? And align means that whether you want the data to be on the left side, right, or center. So I like the data to be center. And measure, we have 3 measures dekat sini. We have scale, ordinal, and nominal. So if you understand, this is a numerical scale, right? So in numerical scale, we have 2 types of scale of measurement, which is interval and ratio. So in SPSS, it sum up these 2 scale, interval and ratio, to as a scale. So dia letak dua-dua ni sebagai scale, right? So we need to identify whether it is a quantitative or qualitative variable. If qualitative variable, we need to understand whether this is a nominal or ordinal. Kalau dia quantitative, we don't need to differentiate between interval and ratio. We just put scale. So the input, dia ada banyak sikit dekat input dia, target, both, none, partition and split. So we just put input sajalah sebab kita we only have one variable, right? So once you're done with the variable definition, then we need to go to data view, right? Data view and start key in the data. 147, oops, 147, 159, 153, 146, 144, 148, 163, 153, and this is 143, and last is 158. So we overall we have 10 observation lah, 10 data. So as indicate in SPSS, dalam example number 13, we only have 10 data, so sama lah. So now, if you want to find the point estimate, mean and variance, right? So you just need to go to analyze and click on descriptive statistics. So there are many ways to get mean and variance in SPSS, right? So either you can use a frequency, descriptive, explore, right? Population descriptive also can. Dekat compare mean also, they will give you a mean and standard deviation. But we just want to know what is the mean and variance. So I prefer to use descriptive. So sebab dua value saja kan, descriptive. So you also can click on explore, right? But in this example, we just try to use a descriptive dulu lah. Descriptive. Once you click on descriptive dialog toolbar, right? So you can nampak dua box dekat sini in this dialog box. We have 2 box. The first box is all the variable in your dataset. So since you only have one variable, you letak satu je lah. So on the right hand side, so we have a box for variables. So this is the box for which variable that you want to analyze, right? So let's say kita ada satu saja kan, kita masuklah this only one variable that we want SPSS give us the value of mean and variance, right? And then we click on option. So option dekat sini dia ada beberapa option lah. So by default, SPSS will tick for you mean, standard deviation, minimum value and maximum value. So we just want variance and mean, right? So we untick minimum value and maximum value, right? So we just need mean and standard deviation. So we click continue and click OK lah. So where is my result? So then you will see this kind of result. So this is what we call as our statistical output viewer lah. So this is output viewer file. So in output viewer file, it will give us the value of mean and number of observation, mean and variance. So the mean is 151. So we can put here lah 151.40. And this is 47.378. And of course, when you are doing assessment 1 and final assessment, you need to calculate this one manually lah, alright? This is for practical reason lah, sebagai I nak tunjuk dekat you how to get mean and standard and variance using SPSS. Right, so the next one is we want to construct a 99% confident interval for mean of mean number of calorie in the carbs. So we need to click on analyze, compare mean, right? And then we click on means. Kita masuk, saya tengok dulu dapat tak. This one just want to get mean value kan. Alright, no worries. So we just go to analyze, compare mean, and one sample t-test. One sample t-test. So dalam one sample t-test again analyze, compare means, and click on one sample t-test. Right. So again benda yang sama you akan dapat. Right. But this one require some test value. So test value dekat sini dia ada dalam question number 2. Means that we want to know whether the mean number of calories is less than 100. Right. So we can put test value should be less than 100. So this one is not less than, but dia akan kira based on t value, right? Two-sided. So kita akan masukkan the value of the variable that we want to analyze kat sini, and then option. So since we want 99%, so dekat option ni by default SPSS will calculate 95%. So you need to change from 95% to 99%. Right, so you remember by default is 95%. Right, so we change it to 99% and click continue and click OK. So then we will get the confidence interval for mean. So is there any confidence interval for mean? Oh, tak ada. Dekat sini confidence interval for mean tak ada. So dia bagi dekat kita confidence interval of the difference, of the difference. So remember kita dah belajar of the difference menggunakan this formula kan, mana this one, confidence interval for mean difference, right? So mean difference dekat sini lah. So if you want to find the confidence interval of the mean, I just remember we cannot get it from here. We need to get it from explore. So we need to go to descriptive statistics, analyze descriptive statistics, and click on explore. So explore, they will give us the confidence interval of the mean. So kita masuk kat sini. Dalam explore ni kita akan nampak 3 kotak dekat tepi kanan ni. So dia ada dependent list, factor list, label cases. So we just put into dependent list. And then statistics, we instead of 95%, we change it to 99% and click continue. Right, again statistics, instead of 95%, kita click on 99%, click continue, and display only statistic, right? Option nothing to change lah, and click OK. So now they will give us the value of confidence interval for mean. So upper bound and lower bound. So dekat sini kita nampak dia punya soalan, dia kata apa? Where is the question? So this is the confidence interval of the mean for 99%, right? So the lower confidence interval is 144.33 and the upper confidence interval is 158.47. So this is the confidence interval for the mean. And can we conclude that the mean number of calories carb is less than 100? So no lah. It is more than 100 because the confidence interval is lies between 144 until 458 lah. Right? Boleh? So this is how we use SPSS to obtain the statistical value lah yang dia nak. Right. So of course in assessment 1 and final assessment you need to calculate manually lah. You cannot show the end result. Right. So let's look at the next topic for today. So since we already learned on point estimation, right? So mean and standard deviation. We also learn normal distribution, right? How to find the probability of x less than some numbers, right? We need to convert it to a standard normal distribution, right? And then find the probability value, which is area under curve. And we already learned about confidence interval of the mean, confidence interval of mean difference, right? So when to use T distribution and when to use Z distribution, right? Still remember? So now we're going to look into when we have two population or two samples, right? When you have two samples, let's say you have population A, sample number A and sample B. So you have mean for A is, let's say some value 15.4, XB equal to 15.6, and SA should be 1.05, SB equal to 1.25 contoh for example kan. So if you have two samples, right, from one population or two population, so we want to know whether the mean of A is equal to mean of B, right? Remember on chapter number 2, we already learned of coefficient of variation. So we want to know which one is consistent, right? So now the objective is we want to know is A and B are equal distributed, right? So to know whether there is a difference between A and B or there are no difference between A and B, so we can calculate it by using confidence interval for difference of two means, right? So there are two characteristics here, right? If you notice, so there are equal variance and unequal variance, right? So the value that we want to measure is mu1 minus mu2, right? We want to know whether mean for population 1 and population 2 is equal to 0 or not equal to 0. Later on I will explain whether about this, right? For now we want to know the difference, right? Is the difference equal to 0 means that there is no difference lah. If there is a value is not equal to 0, then we can say that there is a difference between A and B. So if we have equal variance means that population A and population B are equal. The variance of population A and B are equal. So we can use T distribution with a pooled standard deviation. Right. And when we have distribution with unequal variance, right, still we are using pooled standard deviation, Sorry, no. I think this is terbalik. When we have unequal variance, so we need to pull standard deviation. When we have equal variance, we don't need to pull standard deviation. Okay, I think this is correct one lah. Yes, correct. So when we have unequal variance, when we have equal variance, then we're going to use pool standard deviation. When you have unequal variance, then we use different standard deviation lah, different variance. That's why we have two variants, right? So so pool standard deviation means that we're going to pool two standard deviation into one standard deviation. So the formula of pool standard deviation is n1 minus 1 multiply with standard deviation for population number 1 for sample number 1. So this is a standard sample variance number 1, and then plus with n2 minus 1 multiply with s2 square, right? So this is a variance for sample number 2, and divide by the degree of freedom, which is n1 plus n2 minus 2, right? So since this is a equal variance, so we can simply using n1 plus n2 minus 2. So this is a pool standard deviation. Yes. And then the degree of freedom, right? When you have unequal variance, right? So we need to use S1 divide S1 square divided by N1 plus S2 square divided by N2, and then you square this one, right? And then divide by each one minus 1. So now, how to know whether the data is having equal variance or unequal variance? So to know whether the data is having equal variance or unequal variance, then we're going to use a Levene's test. Levene's test shown in SPSS output, right? So equality of variance of two independent group can be determined by using Levene's test, right? So Levene's test is a advanced or modified version of Welch test distribution, right? So the hypothesis of equality of variance. So ini kita akan masuk detail, but this is for pengenalan lah. As you need to understand the null hypothesis and alternative hypothesis. So in hypothesis we have two type of hypothesis. Whether the null hypothesis, which is H null, right? Alternative hypothesis, sometimes the book will say HA or H1, right? So there are two symbols for an alternative hypothesis, but it still mean the same things. So on hypothesis, we only test on null hypothesis, right? So the null hypothesis is the variance are equal for both group, right? The alternative hypothesis means that the opposite of null hypothesis, means the variance are not equal for both group, right? So this is the hypothesis for equality of variance. So by using a Levene's test, right? So decision rule, right? So when, let's say our alpha is 0.05, this is for 95% confident interval, right? So if 95% confident interval, alpha will be 0.05. So if p value is less than 0.05, right? So Let's draw like this. Okay, this is the 0.05. Let's say p-value is less than 0.05, means that we're going to accept sorry sorry, this is tak sama, right? So if the p-value is less than 0.05, we're going to reject null hypothesis and we conclude that variance are equal for both group. We're going to reject null hypothesis and we're going to conclude variance are unequal for both group. Okay, again, so maybe you are confused a bit. Okay, I ulang balik daripada mula. So to test equality of variance for both for two groups, right? So we're going to use Levin's test, right? So Levin's test, the hypothesis is null hypothesis, variance are equal. Alternative hypothesis, the opposite of null hypothesis, which is not equal variance. So we're going to depend on p-value. So to look into p-value, we need to understand the alpha value. We need to have alpha value. Alpha came from 95% confidence interval or 99% confidence interval or 97% confidence interval. So 1 minus 95%, 100 minus 95%. So you will get 5%. For 5%, alpha is 0.05. So if p-value is less than alpha, which is 0.05, we're going to reject null hypothesis. We reject null hypothesis and conclude alternative hypothesis, which is the variance are not equal. If the p-value is more than 0.05, we're going to accept null hypothesis and reject alternative hypothesis. So when we accept null hypothesis, so we conclude that the variance are equal. Boleh faham? Boleh setakat ni? Ulang sekali lagi ke? Ulang sekali lagi . So to test the equality of variance, we're going to use Levin's test. So Levin's test, we have two hypotheses, two type of hypothesis, null hypothesis and alternative hypothesis. Null hypothesis means that the variance are equal for both group. Alternative hypothesis, the opposite of null hypothesis, which means the variance are not equal for both group. So to conclude, you need to have a decision rule. So the decision rule for Levin's test is if p-value is less than alpha, alpha is our threshold, our threshold, our benchmark, which is, let's say, 95%, so alpha will be 0.05. 99%, alpha will be 0.01. 97% confidence interval, alpha will be 0.03. So how to get alpha? 100 minus 95%, right? So you're going to dapat 5%. So alpha will be 0.05. So alpha is the probability value. So we need to express it in term of probability punya value lah. Probability value, remember last class, probability must lies between 0 and 1. So that's why kita convertkan dia menjadi within the probability value lah. Means 5%, 5 divided by 100, which is 0.05. Right. So if the p-value is less than 0.05, which is our alpha, so we're going to reject null hypothesis. So we're going to conclude alternative hypothesis, which is the variance are not equal. If the p-value is more than 0.05, we're going to accept null hypothesis and we conclude the null hypothesis where the variance are equal. Right, boleh faham ulang 3 kali dah ni. Right, so now this is a SPSS output for different of two means, or commonly known as two independent sample means. So when we have two independent, so what does it mean by two independent sample? So let's say we have two group, right, A and B. So NA is 10, NB also 10. So we have a equal or balanced group. So 10 apa ni? This is 10 children playing at the playground A and 10 children playing at playground B. So the mean of age of A, let's say 4 years old. Mean of B, let's say also 4 years old. As A, let's say 1.05. As B, let's say 1.35. Right? So children at playground A and children at playground B are not the same person. So this is not related to A and B. Children in playground A is not related to children in playground B. Means that this is not a same person. Apa contoh same person? Same person means that when you have let's say entrance survey, right? Entrance survey and exit survey. Remember, every semester, starting the semester, you will fill in entrance survey, and then at the end of the semester, you will fill in exit survey. You are the same person will fill in entrance and exit survey, right? So ada dua dataset dekat situ, entrance survey, exit survey. So dua dataset. So dua-dua ini related. Means that you are the same person fill in two form, entrance and exit. Right? Itu dipanggil dependence sample. So, independent sample means that dia tak ada related langsung. A and B, no relationship. Okay? So this is the SPSS output for independent sample t-test, or two independent sample means. So first it will give you the group statistics, right? The group statistic, which is include the mean value, standard deviation, and standard error of the mean. So standard error of the mean is getting from x bar divided by s square root of s divided by n. Right? So remember, this one standard error of the mean kita belajar hari itu, x bar divided by s over n, right? S square over n. So you will get the standard error of the mean, right? And then this is the Levin's test. Kalau kita tengok dekat sini, table number 2, independent sample test. So t-test equality of mean. So the first half dekat sini, right, of the table is Levin's test of for equality of variance. So it will give you the two value, f value and significant value. Significant value is also known as p value. Significant SIG dot is also known as p value. Right? So the p value here, we have group A and group B again. The p value is 0.394, which is more than 0.05. So when p value is more than 0.05, which is our alpha, we're going to accept null hypothesis. Accept null hypothesis, we conclude that the variance are equal for both group. So when the variance are equal, right? So kita nampak dekat sini dia ada dua row. The first row which is equal variance assumed. The second row represent equal variance not assumed, right? So when the Levin's test indicate that equal variance is assumed, right? The two group are equal, having equal variance. So you're going to read on row number 1, and you ignore row number 2, right? When the p-value of Levin's test is less than 0.05, so we're going to accept alternative hypothesis, which is unequal variance. All right, so we're going to read row number 2. Boleh faham? This is how we read SPSS table lah. So in the SPSS table, result for equality of variance, t-test equality of means, right? Okay, so they give us the value of t value 0.975 with the degree of freedom 28. Ni mana dapat ni? N1 plus N2 minus 2. So maksudnya 15 tambah 15, which is 30 minus 2 equal to 28. Right? And this is the p-value. P-value. Right? P-value. So this is a mean difference. Mean difference means that the value of mean number 1. So nampak tak dekat sini? Mean A and mean B. Mean A is 32.1333. Mean B is 29.4500. So 32.13 minus 29.45 is equal to 2.68. So this is the value of mean difference. So the difference of two means, right? And the standard error of the difference means that the mean difference divide by square root of s over n. So s square. So s square is the standard, and is the variance of difference. Variance of difference. So macam mana dapat the variance of difference? You need to get from the original data lah. You need to minus 1 by 1 and then find the variance of the difference. Nanti kita akan tengok the next example. So the last column is about confidence interval. Confidence interval of the difference. So how to calculate confidence interval of the difference? So mean difference. So this is the mean difference. Plus minus t value alpha divided by 2 n minus 1. So this is not minus 1. So this is minus 1 because 28 minus 1. Sorry, this is not minus 1. Salah, bukan minus 1. So this is going to be n1 plus n2 minus 2. Right? You cancel this one. Put it as this one. T alpha divided by 2. Right? n1 plus n2 minus 2. So standard deviation divided by square root of n. So which is the standard error of difference. So this is a standard error of difference, right? So the confidence interval for mean difference, right? For when you have two independent sample, so mean difference plus minus t alpha divided by 2, and the degree of freedom is n1 plus n2 minus 2. Alright, standard deviation of the different divided by square root of n, ataupun this one sama juga, square root of standard variance of the different divided by n, benda yang sama lah. Right, so you just plug in the value into the formula. So you need to find the mean difference, which is 2.6833 plus minus t 0.025, right, and 28, and this is 2.75271, right, and then you will get the confidence interval of the difference, which is the last one, this one, negative 2.95 and 8.32. So when the confidence interval include 0 in the intervals, right, is what I cakap, you salin, when the confidence interval of different includes 0 in the confidence length, right, interval, so we can say that there is no difference between two groups. When the confidence interval includes 0 in the interval, so there are no difference between mean A and mean B. Okay, right, this is how we calculate confidence interval of for the mean difference, right? So okay, so this is dependent sample. Nanti kita tengok dependent sample sekejap lagi. So I just want to show you how to get this SPSS output in this output from SPSS. So first we need to go to SPSS, right, and then click on new file, new data, right, file, new data. So you will get a new clean data set. So we have a clean data view and clean variable view. So let's say we create a new variable, let's say set, let's say group A lah, group A. But in SPSS, the data name, the variable name cannot contain any space. So let's say you nampak dekat sini group space A kan, so dia tak boleh masuk, illegal character, so it cannot contain any space. So group underscore A, okay, can group underscore B, right? So let's say I define measure as scale for both group, right? And then I go to data view, I start key in 10 data lah, let's say any data. Say this one should be 2.05. Let's say we have two data kat sini, group A and group B. So both have 6 observation, right? To get this result, right, as I showed before dekat sini, so we need to go to analyze, compare mean, and click on independent sample t-test. Independent sample t-test, and then dekat sini dia ada dua column dekat sini. First column is all variable in your dataset. The second column is test variable and grouping variable. Right. So in SPSS, to key in the data, right, to get a independent sample t-test dekat sini, it's not possible, right? Sebab dia perlukan dua variable. Satu variable is a categorical variable, another variable is continuous variable. If you look into this data, kita ada test variable, which is a numerical variable, another one is grouping variable, which is a categorical variable. So this kind of format is not acceptable in SPSS. So what we need to do is, let's say I copy this one from 6 to 1 to 6, 1 to 6 dekat group B ni, I paste dekat sini. And then for group B ni, let's say this is measure lah, I tulis. I tukar kepada measure, and this is I tukar kepada group. Right? So now dekat sini I nak tukar kepada nominal. I want group to be categorical variable. Right? So then values dekat sini I letak lah 1 for group A, 2 for group B. Right? Boleh sekarang ni? And then I click OK. So now dekat sini ada dua group, dua variable. First is numerical variable, and second is categorical variable. So this is 1 sampai 6, 2 sampai 12. So if I click this one, this icon, value label, so nampak dekat sini lah. This is a group A and this is a group B. Right? So now I can use this dialog, independent sample t-test, untuk masukkan semua dalam ni. So I letak measures untuk numerical value, group dalam grouping variable. So dalam grouping variable, I need to define the group 1 and 2. Click continue. Right? And then let's look at this one. Okay, let's say 95% kan. So kita nak tengok 95% confidence interval. So this is a 95% confidence interval lah by default. But if you want to get 99%, you need to change it here lah. And then click OK. So you will get the result. So this is the two table basically. This one is additional table. We don't want this. We need these two table. The first table is group statistics, which is give us the value of mean, standard deviation, and standard error of the mean. And this is the independent sample test. The first half is Levin's test for equality of variance. The second one is t-test equality of means. So let's look at the p-value for Levin's test. Right, this is the p-value significant 0.276, means that it's more than 0.05. So we can assume that the two variants are equal. The variance for both group are equal. So since the variance for both group are equal, so we're going to read the first column, in the first row. In the first row, we can see the mean difference dekat sini 0.0868. So mana dapat 2.6 minus 2.5, dapat 0.08. And this is the standard error of the mean, and this is the 95% confidence interval of the difference. Boleh? Okay. Boleh? Any questions so far?
No, sir.
Alright, let's continue on the next one, which is confidence interval of two population mean. This is for dependent sample. Just now we are looking into independent sample, right? This is for independent sample, and now we are looking into dependent sample. Dependent sample, as I said before, what's the difference between dependent and independent? Independent means that two groups, the observation in two groups are not related, right? So means that group A and group B, a student in group A and student in group B, right? There are different students. But for dependent sample, you have two data. For the two data, all the observation are same. Maksudnya group A, I measure two times. Maksudnya entrance survey and exit survey. So entrance survey and exit survey answered by same students. So I have 30 students, 30 same students. Right? Boleh faham? So dependent sample, also known as paired sample, t-test in SPSS, compare the means between two related groups on the same continuous dependent variable. For example, does attending a motivation seminar increase the productivity of employees? Means that we can measure the productivity before and after attending the motivation seminar. Type of diet make a difference in weight. So we can compare weight before and weight after for each person. So assumption, there are basically 4 assumptions, right, that required in this when you before proceed with the dependent sample t-test. The dependent variable should be measured continuous scale. Independent variable should consist of two categorical or related group, match or pair. Right? There should be no significant outliers in the difference between two groups. Means that we are measuring the difference of two data. The distribution of difference in the dependent variable must be normally distributed. So means that we need to know the box plot ni mesti symmetrical for the difference. For the data different ni mesti normal distribution lah. So the confidence interval of the difference is still same as previously, but instead of n1 plus n2 minus 2, we are not using this one, right? We are using n minus 1. Kenapa n minus 1? So n of different, right? So now let's look at example. This example shows that student marks over 30 for pre and post of a new teaching method, right? So we have 20 students having taken pre-test and post-test. So we need to measure the difference. So in order to know whether the student has increased their punya level of efficiency or still sama saja ataupun worse, right, dia punya level of efficiency, level of understanding of the subject, right, in the new teaching method. Pre-test means that before the new teaching method imposed. Post-test means that after the new teaching method imposed. So we need to measure the difference of these two marks. So 18 minus 22, so you get the value. And then we don't care whether it's a positive sign or negative sign here, because later on we will do, we take a power of 2 of the difference. So then when we get power of 2 of the difference, so kita can measure the mean difference. The mean difference means that we need to take a value of mean for pre-test minus value of mean of post-test. So we will get negative 2.005. Standard deviation means that, standard deviation of the difference means that you need to, this is the value of difference, right? So standard deviation of the difference sama juga, the formula is still same as before. Summation of d squared minus summation of d, then u squared divided by n minus 1 divided by n, divided by n, then everything divided by n minus 1. Right? Benda yang sama. So you will get, for this example, you dapat berapa? 2.83, right? 2.83, right? So since you already have these two value, mean difference and standard error, standard deviation of the difference, so you just plug into the formula d plus minus t alpha divided by 2 v, which is n minus 1, and then standard error means that, so we already have the standard deviation, so this one should be standard deviation of the difference divided by square root of n, right? So negative 2.05 plus minus t 0.025 with 19, and then this is 2.8373 divided by square root of 20, right? So you need to find the value of t distribution, t value, right? So this one should be 2.093, right? And then you plug in the value and then you will get the answer lah. Okay? Right. This one is quite simple because it's already state here the answer. Nanti kita akan tengok example dekat sini. So I ada bawa sedikit example past your question. So now I'm going to show you how to read confidence interval of the difference between means when we have two dependent sample. So first, as usual, we have mean and standard deviation for each group, pre and post, and then this is the paired sample t-test. Right, the mean here will represent the mean difference. The standard error here will be present standard error of mean difference, which is standard deviation divided by square root of n, right? And then the confidence interval of the difference is mean difference multiplied with t distribution with the degree of freedom 19, right? Degree of freedom 19. Dekat sini degree of freedom 19, dia lupa tulis 19, right? And multiply with standard error, you will get this value lah, this value, right? And degree of freedom is 20 minus 1, right? Remember, for dependent sample t-test, minus 1. Kalau independent sample t-test, plus 2, minus 2, plus n1 plus n2, minus 2. So this is how the SPSS output presented. So now let's look at this data. Let's try to key in this data. So remember dekat sini, this is how the layout for independent sample t-test, right? First variable should be numerical and second variable should be categorical, representing two groups. But it is different for dependent sample t-test. Let's say we click a new data. Right, a new data. So let's say we define the variable new data ni kat sini, the variable view pre-test, pre_test. This is post_test. So illegal character dash to illegal character lah. So now, since both variable have no decimal, kita letak no decimal, measure should be scaled for both group. So notice dekat sini, for dependent sample or related sample, right? So the layout should be like this. It should have two numerical data. So you start key in the data 18, 21, 16, 32, 19, 24. Oh, terlebih. Apa yang lebih Ni ulang banyak kali. 24, 18, 25, 19, 16. This is nothing. So nampak dekat sini, bila I terlebih kan, tadi bila I delete kan, nampak tak bila I delete tadi I letak numbers kan, so terlebih, so I delete, I tekan this one, I delete. So kalau you notice dekat sini, dekat dua variable ni dia ada dot, still have dot, right? Yang bawah ni tak ada dot kan, maksudnya dia SPSS dia tak delete this one. Memang dia delete value, but they still read this one as a observation. So what you need to do is to highlight this one and right click on clear. So baru dia akan kosong. So dia akan ignore, dia akan tahu this is only until 20 observation only. So now, once you already key in the data, you just click on analyze, compare means, and click on paired sample t-test. Kita dalam paired sample or related sample or dependent sample, benda yang sama, paired sample t-test. So click on paired sample t-test, you akan nampak this kind of dialog box. So we have all the variable in the data set on the left hand side. So on the right hand side, the box contain pair 1, variable 1, variable 2. So you just input variable pre-test on variable 1, post-test on variable 2. Cukuplah sebab kita ada dua saja kan. And then option you can choose whether you want 95% or 99% confidence interval. Right, by default is 95%. Click continue. And estimate effect size, we don't want this one. Right, and just click OK. So SPSS will give us the value of the result, right? So this is the mean and standard deviation, right? This is additional information which is correlation, which is nanti kita akan tengok dalam chapter number 5 later on. And this is the result of paired sample t-test, right? Okay. Ada soalan?
No, sir.
Alright. So the next one, page 82, is how to read standard normal this table correctly. This one kita dah tengok lah sebelum ni kan. Okay. This is a example yang nak bawa hari ni. So kita tengok example ni. I give you 10 minutes to copy to your own paper, own sheet, right? Let's continue. So dia kata dekat sini example, on this example, one indicator of physical fitness is resting pulse rate. So 10 men volunteered to test exercise device as advertised on television by using it 3 times a week for 20 minutes. Their pulse rate, beat per minute, were measured before and after 6 weeks of the test. So we have before and after. So the data recorded and analyzed in using SPSS, right? So the results are shown below. So we have a mean of 85.2 for before and 82.0 after, and standard deviation and before and after, standard error before and after. So find value G. G is the mean of difference. So mean of difference means 85.2 minus 82.0, which is equal to 3.2. So 1 mark. So B, prove the T statistic value for the above study. So T statistic is 4.707. So T statistic basically is getting from the mean difference, right? X different, ataupun kita letak D bar lah, D bar divide by standard error of the difference. Standard error of mean difference, right? So how to get this one? So mean difference is 3.2 divided by standard error of the difference. So where is the standard error? Standard error of the difference should be standard deviation of the difference 2.14994 divided by square root of n, which is 10. So this one should be equal to more or less equal to 4.707. Kita ambil calculator tengok. So this one should be 3.2 divided by 2.14994 divided by square root of 10 should be 4.707 lah, right? And then state 95% confidence interval of the mean difference. So 95% confidence interval is here, so which is 1.66203 and 4.73797. So mean difference, right? So at 5% level of significance, is there a sufficient evidence to indicate that this kind of exercise could reduce pulse rate? So we look into, as I said before, if the confidence interval includes 0, means that there is no difference, right? If the confidence interval does not include 0, means that there is a difference. So what kind of difference we have? So by looking at the mean of each result before and after, so it reduces the resting pulse rate, kan? So means that we can say that yes, it reduces resting pulse rate since the confidence interval does not include 0 in the interval, and the mean after is reduced by 3.2 as compared to before test. Right? That's how we answer the question. Right? This is very simple question. So you should not have any false mark lah dalam ni, false answer. So the question is very straightforward, very easy to understand. Right? Kalau salah tu malu lah. Okay, I think that's all for chapter number 3. So be prepared for your test number 1, which is assessment number 1 on 3rd December. Right?